dive into ETH 2.0 a little bit and look at how it is different from Tendermint. And I'd recommend everyone in here, if you're interested and you haven't done your deep dive yet, feel free to read the research article we just posted. It does a really good job of looking at the pros and cons of ETH2 versus Tendermint. So yeah, take it away, Jack. What do you think about ETH2? What are some strong parts of Casper and all that good stuff?
Yeah, I think that there's this trilemma in distributed consensus, and there's liveness, safety, and partition tolerance. And basically, what it comes down to is you can choose two. So partition tolerance is if part of the network goes down, how does the network deal with that? And pretty much all distributed consensus protocols choose partition tolerance. So really your choice is between safety and liveness.
And is another word for that just like not forking?
Yes, exactly.
Okay, cool.
Pretty much the design space is a choice between safety and liveness. So in Tendermint, we have long chosen safety, and the Tendermint protocol will stop if safety is threatened. And allow the human operators that sort of underlie the network to drop back into what we here call social consensus in order to go fix the network. Now, the Ethereum community has actually chosen liveness over safety, which is a different set of trade-offs, and they have, probabilistic finality, the block when they've got signatures from the full 2/3 of the validator set, but that may take some time. So they sort of move the chain forward without the full set of signatures based on probabilities. This can lead to the ability to fork potentially. So yeah, they've made an entirely different set of trade-offs, and fundamentally it's in order to enable a large number of individual machines to validate. Now, we chose a much smaller number of machines to validate. So like the average Cosmos chain has around 150 validators. It would be pretty easy to move this up to around 300 to 400 with current block times. But we haven't really tried to optimize for a large number of validators. Our working theory is that there's only a smaller number of entities in the world that can run secure validators. So the ability for a chain to have many validators is not necessarily beneficial and doesn't really add a whole ton of security. Another thing that they've done is capped the amount of stake that can be staked to each individual validator. This basically ensures that if you have, say, thousands of Ethereum, i.e. big whales, and you want to stake it, you have to spin up a very large engineering effort to manage hundreds of different virtual machines. And this dynamic encourages scale. So it really plays into the hands of organizations that have really competent DevOps and can spin up large server clusters. And we're talking thousands to tens of thousands of machines sometimes. There are, I think, 400,000 Ethereum 2 validators. And of that, around a third is controlled by two entities. So if there's 400,000 and a third is controlled by two entities, each of those entities has on the order of tens of thousands of individual virtual machines validating on ETH2. That's a huge maintenance burden. And, I think, frankly, it has ended up causing a lot more centralization of validation power within ETH2, because instead of trying to democratize it and make it easy for anyone to run a validator that can accept any amount of stake, they've capped the amount of stake in each validator and basically forced anyone who wants to run at scale to run these huge server clusters. And I think that that's why they've ended up with a smaller number of entities able to censor transactions on ETH2.
And it's really interesting how that evolves with the fact that staking derivatives are somewhat inevitable. So they could have predicted Lido but that didn't change how they engineered it. So now we have Lido having such a massive portion of the stake, and a lot of it just due to convenience and liquidity, where liquidity is king, and if the most liquid stake derivative is Lido, then everyone's going to flock there. So that's kind of an interesting concept.